In this video, we're going to go over how to determine whether or not triangles are similar based on a few theorems that we're going to take a look at here. So remember, by definition, two triangles are similar if and only if the following are true. So the angles in one triangle are congruent to the angles in another triangle, and the corresponding side lengths of two triangles are proportional. So we have these following properties that we only need to know the relationships between two or three pairs of corresponding parts to conclude that triangles are similar. So we can use these pieces instead of having to have all the angles congruent or showing that the corresponding sides are proportional. We can use one of these three properties. So we have angle-angle similarity property. So this says if two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. Now, this has to do with the triangle angle sum theorem, which says that all the three angles of a triangle add up to 180. So if two angles are congruent to the other two angles of another triangle, the third angles have no choice, no option other than to be congruent, because they both have to add up to 180. So that's why we just don't have to prove that all three angles are congruent. We can just prove 2 and 2, because the third angles then must also be congruent. We have side-side-side similarity. So this is if three side lengths of two triangles are proportional, then the triangles are similar. So this is just showing all the sides are proportional. So we call that side-side-side. So really, this was number 1 for our first part of the definition. All the angles are congruent. And this was the second one, showing that the sides are proportional. So we also can use side, angle, side. So if the lengths of two sides of one triangle are proportional to the lengths of two sides of another triangle, and the included angles are congruent, then the triangles are similar. So this one's a little bit different. We're going to get to see this on the next screen so that we can actually see what it looks like. But we read it literally the way we see it. So we have one side, the angle that's literally created in between the side and the side. So it's side, angle, side. So let's go ahead and take a look at this one. So we're going to decide whether or not the triangles are similar. So we have to bubble in either not similar or similar. If they are similar, we have to make a similarity statement and choose the property that we know. So we're either going to go angle, angle, side, 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 or side, angle, side. So with this one, we have PQR, and with PQ is 6, and QR is 9. We also have this angle in between. So this is what is meant by the included angle, because I have a side and a side, and it's the angle literally in between those two sides. So right now I have what looks like side, angle, side. Now we can't use that unless it matches the corresponding side and angle of the other triangle here. So the easiest way to do that is if you look at the longest side to the longest side and the shorter side to the shorter side. Now they're already showing us that the included angles are congruent by doing one arc to one arc. Okay. So we're going to check proportionality. We're going to make sure that those sides are in fact proportional. So we're going to look at the shorter side. So we have 6 to 8. And I went from the left triangle to the right triangle. Now I'm going to do the same thing. I'm going to go from the left triangle to the right triangle. So I'm going to go 9 to 12 for the longer sides. So now I just want to check to make sure this in fact does equal when I cross multiply. So if I go 8 times 9 and 6 times 12, so I went a little out of order, but that's okay. So I have 6 times 12 and 8 times 9, and I get 72 equals 72. So this, in fact, does check out. It is proportional. Now we just need to make sure we pick the right property here, which is side, angle, side. So you can see that side, angle, side, side, angle, side. I kind of put that one off to the side just a little bit there, but we can see the property being used. Make sure you're paying attention to the order of how you type this in. So this is STU, so this is actually this triangle on the right, goes STU. So it's kind of the side I didn't have any length for to the shorter side. So I want to do the same thing on this one. Side I don't have any length for to the shorter side. I want to make sure I'm paying attention to that direction. So I want to go RPQ, because this does matter. If I put this out of order, I will get that marked wrong, because S corresponds to R, T corresponds to P, and U corresponds to Q. If I put them out of order, I'm saying that they correspond in a different way. So then I just say SAS, similarity for side, angle, side. All right, So now I have all three sides for these. I just need to check proportionality again. So I'm going to go shorter sides. So I have 4 to 12. And then I'm going to check to make sure that that equals. And I have 5 to 15. And then I also have 6 to 18 for the longest sides. So I just went small, kind of medium, large. Okay, so you can see 4, 5, 6, 12, 15, 18. And now I'm going to reduce. Instead of cross multiplying, since I have 3 fractions, I'm just going to reduce them. Because cross multiplication definitely works just to check if they equal each other. But I can reduce because 12 can divide by 4, 15 can divide by 5, and 18 can divide by 6. So if I do 12 divided by 4, I get 1/3. Because I get 4 divided by 4 is 1, 12 divided by 4 is 3. And now I can reduce 15 and 5 by 5. So 5 divided by 5 is 1, 15 divided by 5 is 3. And then 16 can also divide by 6 and 18. So 6 divided by 6 is 1, 18 divided by 6 is 3. So I give a big green check mark here because 1/3 equals 1/3 equals 1/3. That means all the sides are proportional. The corresponding sides are proportional. So this is similar. And again, we want to pay attention to that order. So I have A, B, C. So I have the blue side to the pink side, right? Or I could say it's the shortest side to the longest side. So I want to do the same thing here. I want to go shortest side to the longest side, or blue to pink. So FED. I want to make sure that order is correct. And now I used side, side, side similarity because I proved the proportion of all 3 sides. All right, the last one here, I have 2 angles for each triangle. So I'm going to focus on the angles on this one. I want to prove angle-angle similarity. So I have 45 and 40. I have 145. So I need to know what's the third angle here. Even though I only need 2 angles, I need at least 2 angles matching, right? And right now I don't have that. So now I'm going to go through and look at the triangle angle sum theorem. And so if I'm just looking at this triangle here, I have 45 plus 40 plus this angle K equals 180. Remember, all the angles have to add up to 180. I could have also done this triangle. I just decided to focus on this one. So 45 plus 40 is 85. 85 plus K equals 180. So now I'm going to subtract 85 from both sides. The 85 minus 85 cancels, and I have K equals 95. So this is 95, not 100, which means that these are not similar because I don't have at least 2 angles, right, matching. And the whole idea here is that if two angles are matching or congruent, then the third angle has to also be congruent. And in this case, that's not going to happen here, right? So this is using our definition and some of our new similarity rules to determine whether or not triangles are similar. I hope that helped, and I'll see you in the next video.